1969 Chevy Nova Race Car Project. 1. Risk Management. Supply chain. We need a special turbochargers for the Nova, but there's a chance it might not arrive on time. To manage this risk, we'll order it from 2 different suppliers. Regulations. The car must meet safety rules for the race. We'll double-check all the regulations to avoid any last-minute surprises. Performance targets. The goal is 3,000 horsepower. If the engine rebuild doesn't hit this target, we'll have a backup plan to adjust the turbo settings. 2. Scope management. Technical specs. The Nova must have a 3,000 horsepower engine and run an 1/8 mile in 3.7 seconds. If someone suggests adding nitrous, we'll review if it fits our original specs. Change control. If during the project someone wants to change the type of tires, they must submit a change request. This ensures any changes are reviewed and approved. 3. Schedule management. Critical path. The most important tasks include getting the engine parts, rebuilding the engine, and testing the car. If the engine parts are delayed, it impacts the whole project. Resource allocation. We'll make sure the best mechanic works on the engine rebuild and the tuning expert handles the performance checks. This helps us use our team's skills effectively. 4. Cost management. Material. We budgeted $250,000 for parts. If we find a cheaper supplier, we'll save money. Labor, paying the team $200,000 for their work. We'll track their hours to stay on budget. Overhead estimation. We estimated $100,000 for overhead costs like electricity and rent for the workshop. We'll monitor these costs to avoid overspending. 5. Quality management. Inspection. After assembly, the Nova will be inspected to ensure it meets all safety and performance standards. Testing. We'll test the car on a track to make sure it runs the 1/8 mile in 3.7 seconds. Industry standards. The car's build quality must meet professional racing standards. We'll use high-quality parts and skilled labor. 6. Stakeholder management. Race teams. Communicate with the racing team to understand their needs and expectations. Sponsors. Keep sponsors updated on the project's progress. If they want their logos on the car, ensure it's done. Regulatory bodies. Make sure we follow all racing rules and safety regulations. 7. Communications management. Engineering. Regular meetings with the engineering team to discuss progress and any issues. Fabrication coordination. Daily check-ins with the fabrication team to ensure the car is being built correctly and on time. Examples using the 1969 Chevy Nova project. Risk management example. Issue. The turbochargers we ordered might be delayed. Plan. We order it from another supplier too, just in case. Scope management example. Issue. Someone suggests adding nitrous to the Nova. Plan. Review if this change fits our original project specs and get approval. Schedule management example. Issue. The engine parts are delayed. Plan. Prioritize getting these parts as soon as possible to stay on track. Cost management example. Issue. Parts cost more than expected. Plan. Find cheaper suppliers or adjust the budget elsewhere. Quality management example. Issue. The car fails the initial safety inspection. Plan. Fix any issues and re-inspect until it meets all standards. Stakeholder management example. Issue. Sponsors want updates on the car's progress. Plan. Send weekly updates and pictures of the car being built. Communications management example. Issue. The fabrication team misunderstands a part of the design. Plan. Hold a meeting to clarify the design and ensure everyone is on the same page. 1969 Chevy Nova Race Car Project. Building expertise and mastering skills. Understanding key areas. 1. Attend motorsports, automotive manufacturing PM training. Example. Join a workshop that teaches how to manage race car projects, focusing on things like scheduling and cost control. 2. Study books, resources on race car project management. Example. Read books about project management specifically for building race cars, learning from experts in the field. 3. Seek mentorship from experienced race car PMs. Example. Find a mentor who has managed many race car projects and learn from their experiences and advice. 4. Apply learnings on real race car fabrication projects to build expertise. Example. Use what you learned from books and training on the Nova project, improving how you plan and manage tasks. 5. Continuously improve core PM skills for this domain. Example. After each project, review what went well and what didn't, and adjust your approach for the next project. Mastering essential skills. Planning. Master scope definition for custom race car requirements. Example, clearly define that the Nova must have a 3,000 horsepower engine and meet all safety regulations. Own scheduling for integrated engineering/procurement/fabrication. Example, create a detailed schedule that includes when parts should be ordered, when the engine should be built, and when testing should happen. Refine cost estimation for race car materials, labor, tooling. Example, calculate the costs for all parts, labor, and tools needed to build the Nova and make sure it stays within the $550,000 budget. Execution. Lead execution, manage resources for race car builds. Example, oversee the team as they build the Nova, making sure everyone has what they need to do their job. Master change control, issue management for fabrication. Example, if there's a problem with a part, quickly find a solution and get approval for any changes to the original plan. Engage race teams, engineers, fabricators as stakeholders. Example, regularly communicate with the race team, engineers, and fabricators to ensure everyone is on the same page and the project is progressing smoothly. Monitoring control. Monitor performance versus technical specs and budgets. Example, keep track of how the build is going compared to the plan, making sure the Nova meets the 3,000 horsepower goal without going over budget. Implement rigorous quality inspections and testing. Example, inspect the car at different stages of the build and run tests to ensure it's safe and performs well. Manage risk response plans for delays, issues, performance gaps. Example, have backup plans ready in case parts are delayed, there are issues with the build, or the car doesn't meet performance targets. Continually apply and refine these skills on multiple race car projects. Example, use the skills learned from building the Nova on future projects, constantly improving how you manage race car builds. Seek coaching from experienced PMs to enhance capabilities. Example, regularly seek feedback and advice from more experienced project managers to keep improving your skills. Core competencies for managing the 1969 Chevy Nova race car project. Master project management methodologies tailored for manufacturing, fabrication projects. Lean manufacturing principles. Example, use lean principles to minimize waste. For the Nova, make sure only the necessary parts are ordered and used efficiently, avoiding any extra costs. Agile project management. Example, apply agile methods to the project by working in small, manageable tasks. For instance, first focus on sourcing parts, then building the engine, then assembling the car. Critical path method, CPM, scheduling. Example, identify the critical tasks that must be completed on time to meet the deadline. For the Nova, if building the engine is the most time-consuming task, make sure it starts on time and track its progress closely. Earned value management, EVM. Example, use EVM to track project performance. If the Nova build is halfway done and half the budget is spent, you're on track. If more than half the budget is used, there might be overspending. Fictional examples for the Nova project. Lean manufacturing principles. Example, during the Nova build, you notice that a lot of material is being wasted while cutting metal sheets for the car body. You implement a new cutting technique that uses the metal more efficiently, reducing waste and saving money. Agile project management. Example, the team works in 2-week sprints. In the first sprint, they focus on sourcing parts. By the end of the sprint, all that necessary parts are acquired. In the next sprint, they start building the engine, ensuring each part fits and works perfectly. Critical path method, CPM, scheduling. Example, you determine that rebuilding the engine and testing it are critical tasks that will take the longest time. You schedule these tasks first and make sure they start immediately to ensure the overall project stays on track. Cost management and earned value management, EVM, material costs, budgeted, $250,000 earned value, EV, this is the value of work completed so far. If you've purchased materials worth $180,000 by midway through the project, then EV equals $180,000. Actual cost, AC, this is the actual cost incurred for materials. If you've spent $170,000 by midway through the project, then AC equals $170,000. Labor costs, budgeted, $200,000 earned value, EV, if you've completed 50% of the planned labor hours by midway through the project, EV equals $100,000. Actual cost, AC, track the actual labor expenses incurred. If you've spent $90,000 on labor by midway through the project, then AC equals $90,000. Overhead costs, estimated, $100,000 earned value, EV, based on the proportion of work completed for overheads. If you've utilized 60% of the overhead budget by midway through the project, EV equals $60,000. Actual cost, AC, monitor actual overhead expenses. If you've spent $55,000 on overheads by midway through the project, then AC equals $55,000. Calculation example, let's assume midway through the project, EV for materials, EV_M, $180,000. AC for materials, AC_M, $170,000. EV for labor, EV_L, $100,000. AC for labor, AC_L, $90,000. EV for overhead, EV_O, $60,000. AC for overhead, AC_O, $55,000. Interpretation, calculate the overall project's performance metrics, cost performance index, CPI, CPI equals EV, AC overall CPI equals $180,000 plus $100,000 plus $60,000, $170,000 plus $90,000 plus $55,000, equals $340,000, $315,000 equals 1.08 Schedule Performance Index, SPI, SPI equals EV, PV, planned value, if PV, planned value, equals $250,000, materials, plus $200,000, labor, plus $100,000, overhead, equals $550,000 overall SPI equals $180,000 plus $100,000 plus $60,000, $550,000 equals $340,000, $550,000 A 0.62. These indices will help you assess whether the project is on budget, CPI A1 yen, and on schedule, SPI A1 yen. Adjust the actual values based on your project's progress to calculate precise CPI and SPI values. Applying these competencies. Mastering project management methodologies. Example, regularly review project management best practices and adapt them to the Nova build, ensuring the project runs smoothly and efficiently. Lean manufacturing principles. Example, continuously look for ways to improve efficiency and reduce waste throughout the project, from sourcing parts to final assembly. Agile project management. Example, break down the project into smaller tasks and review progress regularly, making adjustments as needed to keep the project on track. Critical path method, CPM, scheduling. Example, always be aware of the critical tasks that could delay the project and take proactive steps to ensure they are completed on time. Earned value management, EVM. Example, use EVM to regularly check the project's health, ensuring it stays within budget and on schedule, making adjustments as needed. By mastering these competencies, you'll be able to effectively lead the build of the 1969 Chevy Nova, ensuring it meets performance, quality, and regulatory requirements on time and within budget. Develop expertise in risk management. Identify and mitigate risks related to supply chain, materials, regulations. Example, for the Nova project, you realize there might be delays in getting some rare engine parts. To mitigate this, you order the parts well in advance and have a backup supplier in case the primary one fails. Implement risk response plans for delays, quality issues, performance targets. Example, during the engine rebuild, you notice a delay because a crucial part was damaged. You have a risk response plan in place, so you quickly switch to using the backup part you sourced earlier, keeping the project on track. Develop expertise in stakeholder engagement. Manage relationships with race teams, sponsors, regulatory bodies. Example, regularly meet with the race team to discuss their needs and expectations for the Nova. Keep sponsors updated on progress and ensure the car meets all racing regulations by coordinating with the appropriate bodies. Facilitate effective communication and alignment with engineering, fabrication teams. Example, hold weekly meetings with engineers and fabricators to ensure everyone is on the same page. Discuss any issues and make sure everyone understands the project goals and timelines. Master scope control for custom race car fabrication. Define clear scope baselines and manage scope changes. Example, Clearly define that the project involves building a 1969 Chevy Nova with a 3,000 horsepower engine. If the race team later wants additional customizations, you manage these changes carefully to avoid disrupting the schedule. Ensure adherence to technical specifications and performance requirements. Example, constantly check that the Nova's engine rebuild is on track to deliver 3,000 horsepower and that the car meets all safety regulations. Any deviations are immediately addressed to stay within the project scope. Examples in action. Risk management. Supply chain risks. Example, you know the specific type of carburetor needed is hard to get. You plan ahead by ordering extra in case the first shipment has any issues. Quality issues. Example, while testing, the car doesn't hit the desired horsepower. You have a plan ready to tweak the engine tuning and try again without wasting much time. Performance targets. Example, to ensure the Nova meets the 3.7-second 8th mile target, you schedule multiple test runs and adjustments to fine-tune performance well before the race. Stakeholder engagement. Race teams. Example, you frequently check with the race team to ensure the car's setup meets their needs and preferences. Sponsors. Example, you send regular updates and photos to sponsors showing progress on the Nova, keeping them excited and informed. Regulatory bodies. Example, you work closely with the racing authorities to ensure all modifications comply with racing rules and safety standards. Scope control. Scope baselines. Example, you document all agreed upon specifications for the Nova at the start. Any changes requested later, like a different paint job, are carefully reviewed to see if they fit the timeline and budget. Technical specifications. Example, regular checks ensure the engine rebuild stays on track for 3,000 horsepower, and any deviation is corrected immediately to meet the project's scope. By mastering these areas, you ensure the 1969 Chevy Nova project runs smoothly, meets its performance goals, stays within budget, and is ready for the race on time. Managing the 1969 Chevy Nova project, scheduling, cost estimation, and quality assurance. Develop scheduling expertise. Create detailed schedules integrating engineering, procurement, fabrication. Example, you make a timeline for the Nova project, detailing when each part should be sourced, when the engine rebuild should start, and when the car assembly should be finished. This helps ensure every team knows their deadlines and the project stays on track. Optimize resource allocation and manage critical path activities. Example, you assign the most experienced engineers to the crucial engine rebuild because it's the most time-sensitive task. By focusing on this critical path, you make sure any delays here don't push back the entire project. Hone cost estimation skills. Estimate material, labor, tooling, and overhead costs. Example, you calculate how much it will cost to buy all the parts, pay the workers, use the tools, and cover other expenses like electricity. For the Nova, you estimate a total of $550,000 for materials and labor, leaving $100,000 for unexpected costs. Develop accurate cost baselines and manage project budgets. Example, you set a budget of $550,000 for the Nova project. As you spend money, you keep track of it to make sure you don't go over budget. If a part costs more than expected, you adjust other expenses to stay within your limit. Ensure quality assurance processes. Implement rigorous inspection and testing protocols. Example, after rebuilding the Nova's engine, you run multiple tests to ensure it reaches 3,000 horsepower. You also check every part of the car to make sure it's safe and works perfectly. Adhere to industry standards and regulations, Street Outlaws NPK, JJ's Arm Drop, NHRA, FIA, etc. Example, you follow all the rules set by racing organizations like NHRA and Street Outlaws. This means making sure the Nova meets safety standards and performance requirements so it can compete in races without any issues. Examples in action. Scheduling. Detailed schedules. Example, your schedule shows that the engine rebuild starts on January 1st, sourcing parts begins on December 1st, and car assembly starts on March 1st. This way, everyone knows what to do and when. Resource allocation. Example, you assign the best mechanics to work on the engine rebuild because it's the most important part of the project. This ensures the critical tasks are completed on time. Cost estimation. Material and labor costs. Example, you estimate that the custom engine parts will cost $200,000, Labor will cost $175,000 and overhead costs like shop utilities will be $75,000. This totals $50,000, leaving some room in the budget for unexpected costs. Cost baselines. Example, as you buy parts and pay workers, you keep a record to make sure the project doesn't go over the $550,000 budget. If one part costs more than expected, you look for ways to save money elsewhere. Quality assurance. Inspection and testing protocols. Example, you test the Nova's engine multiple times to ensure it delivers 3,000 horsepower. You also check the car's safety features, like brakes and seat belts, to ensure they meet safety standards. Industry standards. Example, you follow all the rules from racing bodies like NHRA and JJ's arm drop, ensuring the Nova is safe and legal for competition. This involves checking that the car's modifications comply with racing regulations. By mastering these areas, you ensure the 1969 Chevy Nova project stays on schedule, within budget, and meets all quality and safety standards, ready for the race on June 1, 2024. 1. Risk management. Supply chain. Example, the special turbochargers needed for the Nova might not arrive on time. Plan, order the turbochargers from 2 different suppliers to ensure timely delivery. Regulations. Example, the car must meet all safety rules for the race. Plan, double-check all relevant regulations and ensure compliance to avoid last-minute surprises. Performance targets. Example, the goal is to achieve 3,000 horsepower. Plan, if the engine rebuild doesn't meet this target, have a backup plan to adjust the turbo settings. 2. Scope management. Technical specs. Example, the Nova must have a 3,000 horsepower engine and run an 1/8 mile in 3.7 seconds. Plan, any suggestions like adding nitrous will be reviewed to see if they fit the original specs. Change control. Example, if someone wants to change the type of tires. Plan, they must submit a change request for review and approval to manage any changes properly. 3. Schedule management. Critical path. Example, key tasks include acquiring engine parts, rebuilding the engine, and testing the car. Plan, prioritize these tasks to avoid delays in the project timeline. Resource allocation. Example, the best mechanic will work on the engine rebuild, and the tuning expert will handle performance checks. Plan, this ensures the effective use of team skills. 4. Cost management. Material example, a budget of $200,000 is set for parts. Plan, if a cheaper supplier is found, adjust the budget to save money. Labor. Example, the team is paid $175,000 for their work. Plan, track their hours to ensure the project stays on budget. Overhead estimation. Example, an estimated $75,000 is set for overhead costs like electricity and rent. Plan, monitor these costs to avoid overspending. 5. Quality management. Inspection. Example, the Nova will be inspected after assembly to ensure it meets all standards. Plan, address any issues found during inspection immediately. Testing. Example, test the car on a track to ensure it runs the 1/8 mile in 3.7 seconds. Plan, make necessary adjustments if performance targets are not met. Industry standards. Example, the car's build must meet professional racing standards, for example, Street Outlaws NPK, JJ's arm drop, and HRA. Plan, use high-quality parts and skilled labor to maintain standards. 6. Stakeholder management. Race teams. Example, communicate with the racing team to understand their needs and expectations. Plan, ensure their feedback is incorporated into the project. Sponsors. Example, keep sponsors updated on progress. Plan, ensure their logos are properly displayed on the car if requested. Regulatory bodies. Example, follow all racing rules and safety regulations. Plan, coordinate with relevant authorities to ensure compliance. 7. Communications management. Engineering. Example, hold regular meetings with the engineering team to discuss progress. Plan, address any issues promptly to keep the project on track. Fabrication coordination. Example, conduct daily check-ins with the fabrication team. Plan, ensure the car is being built correctly and on schedule. Building expertise and mastering skills. Understanding key areas. Attend motorsports, automotive manufacturing PM training. Example, Join workshops focused on race car project management. Study books, resources on race car project management. Example, read specialized books on project management for race cars. Seek mentorship from experienced race car PMs. Example, learn from experienced project managers in the industry. Apply learnings on real race car fabrication projects. Example, implement knowledge from books and training on the Nova project. Continuously improve core PM skills. Example, review project outcomes and refine approaches for future projects. Mastering essential skills. Planning. Master scope definition for custom race car requirements. Example, clearly define that the Nova must have a 3,000 horsepower engine. Hone scheduling for integrated engineering/procurement/fabrication. Example, create a detailed schedule for parts ordering, engine building, and car assembly. Refine cost estimation for race car materials, labor, tooling. Example, accurately estimate costs for materials, labor, and tools needed for the build. Execution. Lead execution, manage resources for race car builds. Example, oversee the team to ensure the Nova build progresses smoothly. Master change control, issue management for fabrication. Example, quickly resolve any issues with parts and get approval for any changes. Engage race teams, engineers, fabricators as stakeholders. Example, regularly communicate with all stakeholders to ensure project alignment. Monitoring control. Monitor performance versus technical specs and budgets. Example, track the build progress to ensure it meets specifications and stays within budget. Implement rigorous quality inspections and testing. Example, inspect the car at various stages and conduct thorough tests. Manage risk response plans for delays, issues, performance gaps. Example, have backup plans ready to address any delays or issues. Core competencies. Lean manufacturing principles. Example, minimize waste by using materials efficiently. Agile project management. Example, work in small, manageable tasks and adjust plans as needed. Critical path method, CPM, scheduling. Example, focus on critical tasks to ensure timely project completion. Earned value management, EVM. Example, track project performance to ensure it stays on budget and schedule. By following this detailed project charter checklist, the project manager can effectively lead the 1969 Chevy Nova race car project, ensuring it meets performance, quality, and regulatory requirements on time and within budget.